This is Accelerated Geometry, Section 3.2, which has to do with constructing perpendicular bisectors. We start out with a definition of a segment bisector. A segment bisector is a line, ray, or segment in a plane on a flat surface that passes through the midpoint of a segment that is in the plane. So if I have this segment over here, which is AB, and if O is the midpoint, shown by these two tick marks here, then line L is a segment bisector because it passes through that midpoint. Line N is a segment bisector because it passes through the midpoint of segment AB, and line M is a segment bisector because it is a line that passes through the midpoint of segment AB. Now we get a little bit pickier. We're going to talk about a perpendicular bisector. A perpendicular bisector is a line that divides a segment into two congruent parts. In other words, it goes through the midpoint. And it is also perpendicular to that segment. So back here, the segment bisectors did not have to be perpendicular. They just had to go through the midpoint. A perpendicular bisector not only has to go through that midpoint O, but it has to go through in a perpendicular manner. So therefore, L is the perpendicular bisector of segment AB. So now we're going to discover how to construct that perpendicular bisector of a segment. And I'll just read along with this investigation. Step 1, draw a segment on patty paper, on your loose leaf paper. So just take a ruler, draw a segment PQ, label it P and Q. Fold your patty paper so that endpoints P and Q land exactly on top of each other. That is, they coincide. So P and Q, when you fold this over, will be on top of each other, and that will create a fold here, which you are supposed to crease along the fold. When you open the paper up, on that crease, you are to draw a line. And then it says, what is the relationship of this line that you filled in that crease to segment PQ? If you take a ruler, you will find out that this segment from P to the midpoint is equal to, from this M, I'll call it M for midpoint, to Q, so M is a midpoint. And if you take a protractor, you'll find out that this is a 90-degree angle. So therefore, it is perpendicular to PQ, and it also bisects PQ. How would you describe the relationship of the points on the perpendicular bisector to the endpoints of that bisected segment? So they say, okay, we're going to help you do that. They say, put 3 points on that line that was in the crease and label them A, B, and C. With your compass, compare the distances from P to A and Q to A. So if I stab in with my compass at A and open it all the way to P, from here to here, and then swing my compass, still stabbed in at A, to Q, you'll find out that you do not have to change that compass opening at all, which means that those two distances are equal. If I stab in at B and do the same thing, open up my compass to P and then swing it over to Q, those two distances will be the same. If I stab in at C and open up my compass to P and then swing it to Q, you will also find that these two distances are also equal. So the distances from P and Q to each point are equal. So to A it's equal, to B it's equal, to C it's equal. So we're ready for conjecture number 5. If a point is on the perpendicular bisector of a segment, then it is the same distance or equidistant from the endpoints. Remember that you need to put this on your conjecture list, and you need to draw a figure for this. So let's see what the figure would look like. So let's say this is perpendicular and a bisector, and this is P and this is Q. Then it says if a point is on the perpendicular bisector of the segment, then it is equidistant from the endpoints. So what if I say this is 4 inches and this is 4 inches? So that would be a great picture to go along with that conjecture when you put it on your conjecture list. So you could actually pause the video right now and put that on the conjecture list before you forget to do that. Okay, then there is another investigation, investigation number 2. It says, if a point is equidistant or the same distance from two endpoints of a line segment in a plane, will it be on the segment's perpendicular bisector? If so, then locating two such points can help you construct the perpendicular bisector, because if you know 2 points that are the same distance from each endpoint, and you connect those 2 points, then that would be the perpendicular bisector. So step 1, draw a line segment, which is what they do here in step 1. So they go from here over to here. Set your compass to more than half the distance between the endpoints, and using one endpoint as a center, so they stabbed in here, swing an arc on one side of the segment. Then it says, stab in at the other endpoint, and with the same opening, create another segment. The point where the 2 arcs intersect is the same distance, equidistant, from the endpoints of your segment. Just as you did on one side of the segment, use your compass to find another such point, and use these points to construct a line. So if I stab in here now, and go to the other side, and with the same opening stab in on the other endpoint, then that point is also the same distance from each endpoint. So if it's the same distance from each endpoint, and this intersection spot is the same distance from each endpoint, then if I would connect those two, I have 2 points on the perpendicular bisector, so I have now constructed a perpendicular bisector. Okay, so this has decided not to work right, so there we go again, there we go again. Okay, right, so now here is conjecture number 6. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. Okay, so that would be conjecture number 6. And if I'm going to draw a picture of that, if a point is equidistant from the endpoints of a segment, so here's a segment, and here's a point, and I say this is 6 inches and this is 6 inches, then it is on the perpendicular bisector. Then the point is on the perpendicular bisector. So I could put that in. Okay, constructing a perpendicular bisector. So as usual, I give you the steps. So begin with a segment XY, place the compass at X, adjust the compass radius so that it is more than halfway across the segment, and draw 2 arcs, one above and one below. Without changing the compass opening, place the compass on the other endpoint, Y, draw 2 arcs intersecting the previously drawn arcs, and label the intersection points A and B. And then using a straight edge, draw a line that goes through A and B, and AB will be the perpendicular bisector of segment XY. Okay, I have another video here that you could click on. Other places you could go to are my CMH Accelerated Geometry Links Chapter 3, Constructing a Perpendicular Bisector, to find the same video. You could either click on this YouTube link here, or if that doesn't work, you could copy it and paste it into a browser, and you'll see a person constructing a perpendicular bisector of a segment. Okay, now construct a perpendicular bisector of the segment close to the top of the paper. So let's see if I can do this. I'm going to end the show here. Do I want to keep it? Yes. Okay, so let's go back to that slide. I think that slide is over here. Okay, so now I'm going to bring this down, and I'm going to look at my paper here. Let's say that I have the edge of my paper here, and I have a segment, and I want to do the perpendicular bisector of it. If I have enough room above and below, I can do the regular way to do a perpendicular bisector, which is open it up wider than halfway across, make an arc above and below. You can keep it down also, you don't have to lift it up. And then again, above and below on those. And then I connect those intersection spots, and that will be the perpendicular bisector. If I don't have enough room to go above and below, then I am going to do both of them in the same spot. So I'm going to open this up wider than halfway across. I'll make an arc below, and I'll go to this side and make another arc below. And then I'll open up my compass to a different opening and make another arc below and another arc going through that. And when I connect those, that's also a perpendicular bisector. So I can do the two marks both below the line, or I could do the two marks both above the line. So if I go back to my sketch here for this, see how down here I showed you how I can also go and do these both above the line. Okay, the median of a triangle is a segment from the vertex to the midpoint of the opposite side of the triangle. It says construct two other medians in this triangle. So I'll show that to you here. This is what I did. I went over to this side here and I stabbed in and made an arc, stabbed in here and made an arc. Okay, opened up my compass a little bit wider, stabbed in here, made an arc, stabbed in here, made an arc. And so therefore when I come down here, that comes down to the midpoint. So I find the midpoint, and now I connect from the opposite vertex to that midpoint, and that's a median. Same thing over on this side. I stabbed in and made an arc, and from the other endpoint an arc. Go back here with a different opening of my compass, made an arc. From here, made an arc. So if I connect those two arc intersections, that's a perpendicular bisector of that side, which means this is the midpoint of that side. And then a median goes from the vertex to the midpoint of that opposite side. A midsegment is a segment that connects the midpoint of two sides of a triangle. So if this is a midpoint of that upper side, and this is the midpoint of this lower side, if I connect them with a segment, that's called a mid-segment. So it says construct the three mid-segments in triangle ABC. So if I start here and make an arc from both endpoints, open up my compass a little bit wider, make two arcs coming down, this would be a midpoint. Okay, if I do the same thing to this side, open it up wider than halfway across and make an arc, from B with the same opening, make an arc, open up my compass a little bit wider, from both endpoints make an arc, this comes down, that's a midpoint. And then over here, from A I make an arc, from C I make an arc, open up my compass a little bit wider, from A and C make two arcs, this comes down, and that's a midpoint. And now a mid-segment connects the midpoint. So that's one mid-segment, there's a second mid-segment, and there is a third mid-segment. So that is the notes that I have for section 3.2 of accelerated geometry.